The consciousness paradox. You're sitting in a quiet room, your mind buzzing with thoughts, emotions, and memories. You feel alive, aware of the world around you and the person you are. But then a question creeps into your mind, one that stops you in your tracks. How is it possible for your brain, a mass of neurons, electrical impulses, and chemical reactions, to produce something as rich, personal, and intangible as your conscious experience? How does matter, something you can touch and measure, give rise to consciousness, which you can only feel? This is the consciousness paradox, one of the greatest mysteries in philosophy, science, and even your own self-reflection. Think about it. Your brain is, at its core, a physical machine. It's made up of cells. Those cells are made up of molecules, and those molecules follow the unyielding laws of physics. Nothing about the movement of electrons or the firing of synapses seems to explain the vivid experience of tasting your favorite food, feeling joy, or even just being aware of your own existence. These sensations, thoughts, and feelings, what philosophers call qualia, don't seem to belong to the physical world. Yet, here they are. You're living them right now. The paradox is this: if your brain is purely a physical object operating under physical laws, how can it generate consciousness, something that feels so distinctly non-physical? And if consciousness is somehow separate from your brain, how does it interact with the physical world at all? You're caught between two impossible ideas, both of which feel equally unsatisfying. Let's explore the first possibility. Consciousness is entirely a product of the brain. This is the stance of many scientists and materialist philosophers. According to this view, your mind is like a computer program running on the hardware of your brain. Neurons fire, signals are transmitted, and somehow, out of this intricate dance, your subjective experience emerges. But here's the problem. No matter how much we study the brain, we can't find consciousness. We can map brain activity, pinpoint the regions that light up when you feel pain or see a beautiful sunset, but none of this tells us why those physical processes create the feeling of pain or beauty. There's an unbridgeable gap between the measurable activity of the brain and the unmeasurable richness of your inner life. Now consider the second possibility. Consciousness exists independently of the brain. Maybe it's something immaterial, like a soul or an energy that transcends the physical. This idea is ancient, found in spiritual traditions and philosophical systems across the world. It's comforting in a way. It suggests that your mind is more than just a biological machine, that there's something eternal about you. But this explanation has its own set of problems. If consciousness is separate from the brain, how does it interact with it? How do thoughts and emotions, which seem so tied to your physical brain, arise from something non-physical? And if your brain is damaged, why does your consciousness seem to change with it? This raises uncomfortable questions about how much of you is tied to your physical body. The consciousness paradox isn't just a philosophical puzzle. It's a reflection of the limits of human understanding. It forces you to confront the possibility that there are aspects of existence we simply aren't equipped to comprehend. After all, isn't it strange to use your conscious mind to try to understand consciousness? It's like trying to see your own eyes without a mirror. And yet, this paradox isn't just about philosophy or science. It's about you. It's about what it means to be alive, to experience the world, to know yourself. It challenges you to think about what you are at your core. Are you just a collection of neurons firing in a specific pattern, or are you something more, a being that transcends the material world? Perhaps the most unsettling truth of the consciousness paradox is that it doesn't have an answer. At least, not yet. But maybe that's the point. Maybe consciousness isn't something to solve, but something to marvel at. The very fact that you can think about this paradox, that you can feel awe, curiosity, or even frustration as you grapple with it, is a testament to the profound mystery of your own existence. So, the next time you catch yourself lost in thought, wondering about the nature of your own awareness, remember this: you are the living embodiment of the consciousness paradox, a puzzle that is as beautiful as it is unsolvable. And in that mystery lies the wonder of being alive. The free will paradox. You stand at a crossroads staring down two divergent paths. The choice feels entirely yours to make: go left or right. But then a nagging question rises in your mind. Is this choice really yours, or is it the inevitable result of every prior experience, every thought, every genetic predisposition, every event that has ever shaped you? The paradox of free will strikes at the core of what it means to be human. If every action you take is caused by prior events, then how can you truly have free will? And if free will does exist, how does it fit into a universe governed by causality, where every effect has a cause? Think about your decision at the crossroads. You might feel free in the moment, believing you could choose either path. But what if that feeling of freedom is just an illusion? What if your decision was already determined by your upbringing, your personality, even the way your brain processes information? From this perspective, free will is like a magician's trick, convincing, but ultimately deceptive. You feel like the master of your fate, but in reality, you're following a script written by forces beyond your control. This deterministic view, rooted in physics and neuroscience, suggests that everything in the universe, including your thoughts and actions, is the result of a chain reaction of cause and effect. Your choice to go left or right isn't a spontaneous act of free will. It's the inevitable outcome of countless variables, stretching back to the Big Bang. If that's true, then are you anything more than a passenger in your own life, watching events unfold as they must? But then there's the other side of the paradox, the undeniable feeling that you do have free will. You felt it when making a tough decision, when resisting a temptation, when choosing to speak out or stay silent. It's woven into how you see yourself as an agent, a doer, a chooser. Without free will, how could you take responsibility for your actions? How could you feel pride in your accomplishments or guilt over your mistakes? The very idea of morality seems to crumble if free will is an illusion. The free will paradox is the collision of these two ideas: the mechanistic universe, where everything has a cause, and the lived experience of freedom, where you feel in control. Both seem true, and yet they contradict each other. How can they coexist? Some philosophers and scientists try to resolve the paradox by redefining free will. Instead of seeing it as absolute freedom, they frame it as the ability to act in accordance with your desires and intentions. Under this view, you're free, as long as you're not being coerced or controlled by external forces. If you decide to go left because you want to, then that's free will, even if your wants are shaped by prior causes. But does this really solve the paradox, or does it just move the goalposts? After all, if your desires are determined by forces outside your control, is your choice truly yours? Others argue for a more radical solution. Maybe free will and causality can exist together if we let go of our need to fully understand them. Quantum physics, for example, reveals that at the smallest scales, particles behave unpredictably with outcomes that aren't strictly determined by prior events. Could it be that our brains operate at this intersection of order and chaos, allowing for just enough randomness to create free will? Or does this merely replace one mystery with another? The free will paradox isn't just a philosophical debate. It's a mirror, reflecting how you see yourself and the choices you make. It forces you to question whether you're a puppet of the universe or its co-creator. It challenges you to confront the uncomfortable possibility that your sense of freedom might be both real and illusory at the same time. And yet, perhaps the paradox itself holds a hidden truth. Maybe free will isn't about escaping causality, but about how you respond to it. Even if your choices are shaped by the past, you still experience the present moment as a space of possibility. You might not control the cards you're dealt, but you decide how to play them. So, the next time you make a decision, big or small, pause and consider this. Are you truly free, or are you following a path laid out by the universe? The answer might not matter as much as the act of choosing itself. In that moment of choice, you embody the paradox. You are both the result of everything that came before and the creator of what comes next. And maybe, just maybe, that's what free will really is. A beautiful contradiction, a spark of freedom within the machinery of causality, a paradox that defines what it means to be alive. The origin of the universe. Paradox. Close your eyes for a moment and try to picture it, a time before time, a place before space, a state of existence before everything began. Impossible, isn't it? Your mind stumbles, searching for a footing that doesn't exist because the very idea contradicts the foundations of how you understand reality. This is the origin of the universe paradox, a question so profound that it ties the threads of logic and imagination into an endless knot. What came before the universe? And if time and space began with the Big Bang, how can there even be a before? Let's start with what we think we know. According to the Big Bang theory, the universe as we understand it, time, space, matter, energy, exploded into existence roughly 13.8 billion years ago. Before that, there was what exactly? A singularity? Nothingness? Something else entirely? The Big Bang wasn't just the beginning of the universe, it was the beginning of time itself. And here's the catch. If time began with the Big Bang, the question of before becomes meaningless. There was no before, but try telling that to your brain. Your mind instinctively rebels against this idea. It's like staring into a mirror that reflects itself endlessly, searching for an origin that's always out of reach. Everything in your experience tells you that events have causes, that one thing leads to another. You plant a seed and a tree grows. You turn a key and the car starts. Cause and effect are the very fabric of how you understand reality. So when you ask, what caused the Big Bang? And the answer is nothing. It feels like hitting a wall. But what if the problem isn't with the universe, but with the way you're asking the question? Your concept of time is rooted in beginnings and endings, past and future. You think of time as a river flowing in one direction. But what if time isn't a river? What if it's a loop or a sphere or something entirely beyond your comprehension? In some theories of cosmology, time and space are not infinite in the past or future. They are finite, but unbounded, like the surface of a sphere. You can move in any direction, but there's no edge, no starting point. If that's true, then asking what came before the Big Bang is like asking what's north of the North Pole. The question itself unravels. Still, the paradox lingers. If the universe had a beginning, what set it into motion? Some turn to physics for answers, proposing ideas like quantum fluctuations, multiverses, or the existence of a timeless realm where the laws of physics are radically different. Others look to philosophy or theology, invoking the idea of an uncaused cause, something eternal and unchanging that brought the universe into being. But here's where the loop tightens. If everything needs a cause, what caused that uncaused cause? Whether you call it God, the multiverse, or some eternal principle, you're left with the same question. What came before? And then there's another possibility, one that's as unsettling as it is liberating. Maybe the universe has no ultimate explanation. Maybe existence is simply brute fact, something that just is. It's a possibility that forces you to confront the limits of human understanding. You're wired to seek patterns, causes, and reasons. But what if the origin of the universe lies outside the grasp of those tools? What if some mysteries are simply too vast for the finite mind to unravel? The origin of the universe. Paradox doesn't just challenge your understanding of cosmology. It challenges your understanding of yourself. It forces you to confront the fact that you're a creature bound by time, trying to grasp something timeless. You can imagine infinity, but you can't truly comprehend it. You can conceptualize a beginning, but the idea of nothing before it eludes you. So, where does this leave you? In a sense, exactly where you started, staring into the void, searching for an answer that may never come. And yet, perhaps that's the paradox's greatest gift. It reminds you that some questions are bigger than answers, that wonder and curiosity are their own rewards. The fact that you can even ask, what came before the universe, is a testament to the vastness of your imagination, a tiny spark of inquiry in a universe filled with mystery. The next time you gaze at the stars, remember this: the question of the universe's origin may never be solved, but it's in asking, in wondering, that you connect with something far greater than yourself. The paradox is not a failure of understanding. It's an invitation to marvel at the sheer improbability of existence itself. The infinity paradox. You're standing at the edge of a vast desert, staring out at the endless horizon. No matter how far your eyes wander, the expanse stretches on, unreachable and unknowable. Now imagine walking forever, step after step, mile after mile, with no destination in sight, just infinite sand, infinite sky. The concept feels impossible, doesn't it? Yet this is the infinity paradox, the strange, ungraspable idea that something can have no limits, no end, no boundaries. Whether it's the universe, time, or numbers, infinity isn't just a concept. It's a confrontation with the limits of human understanding. Think about numbers. You've counted before, perhaps to pass the time, but no matter how high you count, you can always add one more. 1 billion, 1 trillion, 1 quadrillion. And then what? Numbers stretch on forever, a sequence without an endpoint. And yet, you can never hold infinity in your mind. You can picture a large number, a mind-bogglingly large number, but infinity isn't just big. It's beyond. It's everything, and it's nothing, all at once. Now turn your attention to space. Astronomers tell us the universe may be infinite, but how do you even begin to comprehend such a thing? If you traveled to the edge of the cosmos, if such an edge exists, what would you find? a wall, and what's beyond that wall? Another wall? More space? The very idea of infinity sends your thoughts spiraling, because every time you try to pin it down, it slips through your fingers like grains of sand. Then there's time. Imagine a clock ticking forward endlessly. Days become years, years become millennia, and yet time never stops. But infinity doesn't just stretch forward, it also stretches back. What came before the Big Bang? What came before that? No matter how far back you go, there's always more. Infinity doesn't just challenge your understanding of the future, it unsettles your sense of the past. How can something have no beginning, no end, no finality? The paradox deepens when you consider infinity's contradictions. Mathematicians have wrestled with these for centuries, and their discoveries only make the concept stranger. For example, there are different sizes of infinity. It sounds absurd, but it's true. The infinity of whole numbers is smaller than the infinity of fractions or decimals. And here's the kicker. No matter how many numbers you cram into one infinity, it's still infinite. It's a paradox within a paradox, a reminder that infinity doesn't play by the rules you know. Infinity also reveals the limits of your mind. You're wired to think in terms of beginnings and endings, cause and effect, boundaries and borders, but infinity exists outside of all that. It's not something you can see or measure, it's something you can only grasp in fleeting glimpses. When you try to understand it, you end up chasing your own thoughts in endless loops, always coming back to the same unanswerable questions. And yet, infinity is everywhere. It's in the way you can always divide a piece of string into smaller and smaller pieces, never quite reaching the end. It's in the stars above you, in the possibility that space has no edge. It's in the seconds that stretch into eternity as you wait for something, anything, to happen. Infinity isn't just a mathematical abstraction, it's woven into the fabric of reality, into the very structure of existence. The infinity paradox doesn't just confuse, it humbles. It forces you to confront the fact that there are aspects of the universe you will never fully comprehend. And maybe that's the point. Maybe infinity isn't meant to be understood. It's meant to be felt, to remind you of the vastness beyond your grasp. The next time you find yourself staring at the stars or lost in the endless spiral of your own thoughts, consider this. Infinity is not a problem to solve. It's a reminder of how small you are and how extraordinary it is that you're here to ask the question at all. Infinity is both a boundary and its absence, a riddle without an answer, a paradox that stretches forever. And in that infinite mystery lies something beautiful, the knowledge that some things are too vast, too profound, to fit within the walls of your understanding. Infinity doesn't just defy comprehension, it invites awe. The God paradox. Close your eyes and imagine the entirety of existence, the vast universe, the stars, the planets, life itself. Now go one step further. Imagine the being said to have created it all, God, a being so immense, so powerful that nothing escapes its grasp. But then comes the question that twists your thoughts into a knot. If God created everything, who or what created God? How does a being exist without a beginning? How does something create itself? This is the God paradox, a question as ancient as human thought, as perplexing as the universe itself. The paradox begins with a simple chain of logic. Everything you know has a cause. A tree grows from a seed, the seed comes from another tree, and so on. The universe, with its intricate laws and staggering complexity, seems no different. If it exists, it must have a cause. For many, that cause is God, a being outside of time and space, powerful enough to bring everything into existence. But if everything must have a cause, doesn't that rule apply to God? If God exists, who caused God? And if nothing caused God, doesn't that break the very rules we use to understand the world? This line of thinking is maddening because it loops endlessly. If God was created by something else, then you're left asking, what created that something? If God created itself, you're left wondering how something can create itself before it exists. And if God is eternal, without beginning or end, your mind stumbles over the sheer weight of the idea. You've never encountered anything eternal before. Everything in your experience has a start and a finish. How can something simply be forever? Some try to resolve the paradox by redefining God. In many religious and philosophical traditions, God isn't seen as a being bound by the rules of time, space, and causality. Instead, God is described as eternal and self-existent, something that exists outside the chain of cause and effect. From this perspective, asking who created God is like asking what's north of the North Pole. It's a category error, a question that doesn't apply to the nature of God. But while this answer might satisfy a theologian, it leaves most of us feeling uneasy. You can accept the idea of a timeless, uncaused being, but you can't fully understand it. Others tackle the paradox by flipping it on its head. Maybe the question isn't about God at all. Maybe it's about you. Perhaps your inability to comprehend an eternal being says more about the limitations of your mind than it does about the nature of existence. You're wired to think in terms of beginnings and causes, but what if reality isn't bound by those rules? What if the universe, or God, or whatever lies beyond, operates in ways that defy human understanding? But even this explanation leads to more questions. If God is uncreated and eternal, why assume the universe itself isn't? Why invoke God at all? Some philosophers and scientists argue that the universe might be self-existent, a kind of cosmic loop with no beginning or end. Others propose that our concept of time might be flawed, that asking what came before is meaningless when applied to something outside the flow of time as we know it. And yet, the God paradox persists. It persists because it's not just a question of logic or cosmology, it's a question of meaning. If God exists, what does that mean for you? If God doesn't exist, what does that mean for you? The paradox forces you to confront the biggest questions of all. Why is there something rather than nothing? Why are you here? What does it all mean? Maybe the God paradox isn't meant to be solved. Maybe it's meant to remind you of the limits of your understanding, to humble you in the face of existence. The very fact that you can ask these questions, that you can wrestle with the infinite, is a miracle in itself. So, as you ponder the God paradox, remember this: whether God exists or doesn't, whether God was created or always was, the mystery itself is a gift. It's an invitation to wonder, to explore, to reach beyond the edges of what you know. And perhaps the greatest paradox of all is that in seeking answers about God, you might just discover something profound about yourself. The quantum superposition paradox. Picture this: a tiny particle, smaller than anything you can see, sitting in front of you, except it's not really sitting. It's everywhere it could possibly be, all at once. It exists in multiple states, in multiple places, in multiple conditions, simultaneously. This is quantum superposition, one of the strangest ideas in science, and it leads to a mind-bending paradox. How can something exist in multiple states at the same time? And why does the mere act of observing it cause this magical ambiguity to collapse into a single, definitive reality? To grasp the strangeness of this paradox, consider one of quantum physics' most famous thought experiments, Schrödinger's cat. Imagine placing a cat inside a sealed box with a radioactive particle, a vial of poison, and a detector. If the particle decays, the detector breaks the vial, and the cat dies. If it doesn't decay, the cat lives. But until you open the box to observe what's happened, quantum mechanics says the cat is both alive and dead, existing in a superposition of states. Absurd? Absolutely. But this isn't just a metaphor. It's a reflection of how particles behave at the quantum level. Take an electron, for instance. Instead of being in one place, it's described as a wave function, a mathematical cloud of probabilities. It's everywhere it could possibly be until you look. The moment you observe it, the wave function collapses and the electron chooses a single state. But why? And how does your observation, your mere act of looking, hold so much power? The paradox deepens when you realize this isn't just a quirky feature of electrons or Schrödinger's theoretical cat. This strange duality, where a particle exists in all possible states until observed, is at the heart of quantum mechanics. It's how reality operates on its smallest scales, but it completely defies the way you experience the world. A ball is either in your hand or it isn't. A light switch is on or off. There's no both in your everyday reality. What makes quantum superposition even more baffling is the role of observation. In classical physics, objects exist whether or not you're looking at them. A tree in the forest is still there, even if no one sees it fall. But in the quantum world, observation changes everything. When you measure a particle, you force it to decide on a single state. Before that, it exists in a realm of possibility, an in-between world that makes no sense within the framework of your everyday experience. This leads to uncomfortable questions. What does it mean to observe something? Does it require a human mind, a conscious observer? Or is it enough for a particle to interact with another particle? The answers remain elusive, and the implications are profound. If observation plays such a pivotal role in shaping reality, then what exactly is reality? Is the universe itself a kind of quantum wave function, collapsing into existence because we're here to see it? Some scientists and philosophers propose solutions to the paradox, but none are fully satisfying. The Copenhagen interpretation says the wave function's collapse is just a fundamental part of quantum mechanics, a mystery we must accept. Others, like the many worlds interpretation, argue that the wave function never collapses. Instead, every possible outcome happens in its own parallel universe. In one universe, Schrödinger's cat lives. In another, it dies. You just happen to exist in the version where the outcome aligns with your observation. But does this solve the paradox, or does it create new ones? If there are infinite parallel universes, how do they interact? And if the wave function doesn't collapse, why do we experience a single coherent reality? The quantum superposition. Paradox isn't just a scientific puzzle, it's a philosophical one. It forces you to confront the limits of your understanding, the strange rules that govern the universe, and the unsettling idea that your perception of reality might shape its very fabric. So, What does this mean for you? It means the world isn't as solid or predictable as it seems. It means there are layers of reality you can't see, layers that don't obey the logic of cause and effect, here and there, now and then. And it means that your act of observing, of simply being aware, is deeply intertwined with the universe's unfolding story. The next time you look at the world around you, remember this: what you see is just one version of reality, a fleeting moment in an endless sea of possibilities. The quantum superposition paradox reminds you that the universe is far stranger, far more mysterious, and far more beautiful than you could ever imagine. And in that mystery lies the wonder of existence itself. The Fermi paradox. You look up at the night sky, a vast canvas of stars stretching endlessly in every direction. Each tiny point of light represents a sun, and around many of those suns, planets orbit, some of which could be just like Earth. With billions of stars in our galaxy alone, and trillions of galaxies beyond, the math seems clear. Intelligent life must be out there, somewhere. So why haven't we heard from them? Why is the universe so deafeningly silent? This is the Fermi paradox, a haunting question that forces you to confront the unsettling possibility that we might be utterly, completely alone, or that something far more ominous is at play. The paradox begins with numbers. Our galaxy, the Milky Way, contains around 100 billion stars, many of which have planets in the so-called habitable zone, where conditions could support life. If even a tiny fraction of those planets harbor intelligent civilizations, there should be millions of advanced species out there. With the universe being over 13 billion years old, many of these civilizations would have had ample time to develop technologies far beyond our own, perhaps even capable of colonizing the galaxy or signaling their presence across the cosmos. And yet, as far as we can tell, there's nothing, no signals, no evidence, just silence. This silence is what makes the Fermi paradox so unsettling. If the conditions for life are so widespread, where is everybody? Are we truly alone in the vastness of space, the only conscious beings in a universe brimming with potential? Or is the quiet a clue, a warning, that something is keeping intelligent life hidden? Or worse, wiping it out? One possible answer is that intelligent life is extraordinarily rare. Maybe we're a cosmic fluke, the result of an improbable chain of events that came together just right. Life might require such specific conditions that even in a universe filled with stars and planets, we're the only ones who made it this far. The silence, in this case, isn't mysterious. It's the sound of an empty universe, vast and indifferent. But another explanation is far more chilling. What if intelligent civilizations do arise only to destroy themselves before they can reach out to the stars? This idea, known as the Great Filter, suggests that somewhere along the path from single-celled organisms to advanced spacefaring societies, there's a near impossible barrier, something so catastrophic that most civilizations never make it past. Maybe it's the development of destructive technologies like nuclear weapons or climate-altering industries that inevitably lead to extinction. If the Great Filter is ahead of us, then we're staring down the barrel of our own destruction. There's also the possibility that intelligent civilizations are out there, but deliberately avoiding contact. Maybe they're observing us, like scientists watching a colony of ants, waiting for us to develop further, or to prove we're worth talking to. Or perhaps they've established a kind of cosmic prime directive, avoiding interference with less advanced species. This is both comforting and disquieting. We might not be alone, but we're insignificant, unworthy of attention. Then there's the darker possibility. The silence is intentional, a survival strategy. What if the universe is full of predators, advanced civilizations that destroy others on sight? In this scenario, any civilization smart enough to reach the stars also knows better than to announce its presence. The silence isn't emptiness, it's a deadly quiet, born of fear. And if this is true, then by broadcasting our own existence through radio signals and deep space probes, we might be painting a target on our backs. But maybe the answer is less sinister. Perhaps we've simply been looking in the wrong way. The universe is unimaginably vast, and our search so far has barely scratched the surface. Alien civilizations might communicate in ways we can't detect, using technologies we can't even imagine. Or they might exist in forms that defy our understanding of life, machines, energy beings, or something entirely beyond our comprehension. The silence, in this case, isn't evidence of absence, but of our own ignorance. The Fermi paradox forces you to confront profound questions about existence, not just out there in the stars, but here on Earth. What if we are alone? What does it mean to be the only conscious beings in a universe so vast? And if we're not alone, why hasn't anyone answered? The paradox is a mirror, reflecting humanity's deepest fears, hopes, and vulnerabilities. As you stare into the night sky, the silence seems heavier, more profound. But maybe the true answer lies not in solving the paradox, but in understanding what it reveals about us, whether we're alone or surrounded by unseen neighbors. The silence invites us to reflect on the fragility of life, the wonder of existence, and the responsibility we have to protect and cherish this one small planet. Because whether we're a singular miracle or part of a vast hidden community, one thing is certain: the universe is watching, and the silence holds secrets we've yet to uncover. The time travel paradox. Imagine stepping into a time machine. You pull a lever, and in an instant, the world around you shifts. Buildings disappear, landscapes transform, and you're no longer in the present. You've gone back in time to a moment decades before you were born. The thrill of possibility surges through you, but then a darker thought creeps in. What happens if you change something? What if, by your actions, the future, your present, ceases to exist? This is the time travel paradox, a conceptual labyrinth that turns the very fabric of reality into a tangled web of contradictions. Consider the grandfather paradox, one of the most famous dilemmas in time travel. You travel back to a time before your grandfather had children. For reasons you can't explain, even to yourself, you interfere in a way that prevents him from meeting your grandmother. The consequences are immediate and chilling. If your grandfather never meets your grandmother, your parent is never born, and neither are you. But if you were never born, how could you have traveled back in time to interfere in the first place? You've created a loop of impossibility, a paradox where cause and effect collapse into chaos. It's not just the grandfather paradox that complicates time travel. The butterfly effect poses an even subtler problem. Imagine you go back in time and make a tiny, seemingly insignificant change, stepping on an insect, moving a rock, or saying a single word to someone. That small change ripples outward, altering events in ways you can't predict. A butterfly flaps its wings, and the weather shifts halfway across the world. The tiniest act could snowball into a reality unrecognizable from the one you left behind? Would you even recognize the future you return to, or would you have erased everything you once knew? The paradox doesn't stop there. Some theories of time travel suggest that the past is immutable, fixed in place no matter what you do. This idea, known as the Novikov self-consistency principle, argues that any attempt to change the past would simply fail, or, paradoxically, become the very thing that ensures the present unfolds as it does. In this view, if you traveled back to stop your grandfather from meeting your grandmother, something would inevitably stop you. Maybe you'd accidentally ensure their meeting instead, becoming a part of the very story you tried to rewrite. Time, it seems, might defend itself. But what if time doesn't defend itself? What if changes to the past create entirely new timelines, splitting reality into countless parallel universes? In this many worlds interpretation, your actions in the past wouldn't alter your original timeline, but would instead spawn a new one. You could prevent your own birth, but you'd still exist in the timeline you came from. The paradox, in this case, isn't a contradiction. It's an explosion of possibilities, a universe fracturing into infinite branches. And yet, even this solution raises unsettling questions. If every action spawns a new timeline, what happens to the original? Do timelines multiply endlessly, creating infinite versions of reality? And what happens to you, the traveler? Are you tethered to your original timeline, or are you forever adrift, a wanderer lost in an infinite multiverse? The time travel paradox also challenges the very nature of time itself. Is it linear, a straight arrow moving from past to future, or is it something more fluid, a loop, a web, or an ever-present now? If time travel is possible, does it mean the past and future already exist, frozen in place, waiting for you to visit? And if they already exist, what does that say about free will? Are you truly making choices, or are you just playing out a script written across the ages? This paradox isn't just a theoretical puzzle. It's a reflection of your deepest fears and desires. Time travel is seductive because it offers the ultimate escape, undoing mistakes, reliving cherished moments, or glimpsing a better future. But it's also terrifying because it confronts you with the fragility of reality and the unintended consequences of your actions. What if you could rewrite the past, but lose yourself in the process? As you step out of the time machine, whether real or imagined, you're left with more questions than answers. Could you change the past without unraveling reality? Or is time travel a trap, a paradox waiting to pull you into its tangled depths? Maybe the real lesson of the time travel paradox is this: time is precious precisely because it flows in one direction. You can't go back. You can't skip ahead. You can only live in this moment, shaping the future with the choices you make now. And perhaps that's the greatest paradox of all. While the idea of time travel sparks endless wonder, the true miracle is the time you already have, the hard problem of consciousness. Close your eyes for a moment and feel the world around you, not just the sounds, sights, and textures, but you, the one experiencing it all. You're not just a machine processing information, you feel it. The warmth of sunlight, the taste of chocolate, the sharp sting of heartbreak, all these are more than just biological processes. They're deeply personal, vividly subjective experiences. But here's the question that stops us in our tracks. Why? Why does it feel like something to be alive? This is the hard problem of consciousness, a puzzle so profound that it shakes the foundations of science, philosophy, and your very sense of self. Science has made incredible strides in understanding the brain. We know how neurons fire, how signals travel, and how the brain processes inputs to produce thoughts, emotions, and actions. But none of this explains the one thing you know with absolute certainty: your subjective experience. Why does the firing of neurons give rise to a rich inner world? Why isn't the brain just a biological computer processing inputs and outputs without any sense of awareness? This gap between the physical processes of the brain and the subjective experience of consciousness is what makes this problem so hard. You can map every neuron in the brain, measure every electrical impulse, and still be left with the same haunting question: why is there an inner life at all? Why do you feel joy when you hear a favorite song or sadness when you lose someone you love? The brain's activity can be described in terms of chemistry and physics, but those descriptions don't capture what it's like to be you. Philosophers call these subjective experiences qualia. They're the raw sensations that make up your world: the redness of a rose, the sweetness of sugar, the sound of laughter. Qualia are deeply personal. You can describe them, but you can't share them. No one else can truly know what it feels like to see the world through your eyes or feel the emotions in your heart. And that's where the mystery deepens. How does the brain, a physical organ governed by physical laws, produce something as ineffable and unique as qualia? Some argue that consciousness is an emergent property, arising naturally from the complexity of the brain. Just as individual water molecules don't have wetness, but a collection of them does, consciousness might emerge from the vast network of neurons firing in unison. But this explanation feels incomplete. It tells you how consciousness might arise, but not why it feels the way it does. Wetness can be understood as a physical property, but subjective experience remains stubbornly outside the reach of physical explanation. Others suggest that consciousness might not be reducible to the brain at all. Perhaps it's a fundamental property of the universe, like space, time, or gravity. This idea, known as panpsychism, proposes that consciousness is woven into the very fabric of reality, existing even in the simplest particles. If this is true, then your consciousness isn't something your brain creates. It's something your brain channels, like a radio picking up a signal. But even this leaves questions unanswered. If consciousness is everywhere, why does it feel so uniquely yours? The hard problem of consciousness also challenges the way we think about science itself. Science relies on objective observation and measurement, but consciousness is inherently subjective. You can't step outside your own mind to study it from the outside, and no one else can access your inner world to verify what you experience. How can you study something that can't be directly observed? And yet, consciousness is the one thing you can be absolutely certain of. Descartes famously said, "I think, therefore I am," capturing the undeniable truth that you exist as a thinking, experiencing being. But beyond that, certainty crumbles. You don't know how you exist, or why, or what it even means to have this strange, ineffable thing called consciousness. Perhaps the most unsettling aspect of the hard problem is that it might not have a solution. Consciousness could be something we're simply incapable of fully understanding, like trying to explain color to someone who's been blind from birth. The very tools we use to investigate the world, reason, logic, and observation, are products of consciousness itself, creating an infinite loop of inquiry that always leads back to where it started. But maybe the lack of an answer isn't a failure. Maybe it's a gift. The hard problem of consciousness forces you to confront the miracle of your own existence, the sheer improbability of being a conscious being in a vast, indifferent universe. It invites you to marvel at the richness of life, the beauty of qualia, and the profound mystery of what it means to be. So, as you sit here, feeling the weight of this paradox, remember this: you don't need to solve the hard problem of consciousness to appreciate its wonder. The very fact that you're aware of it, thinking, feeling, questioning, is the most extraordinary answer of all. The uncertainty principle. Paradox. Imagine trying to pin down a single grain of sand in the vastness of the desert. You reach for it, thinking you've got it, only to find that your very touch shifts it, changes it, and leaves you wondering where it really was in the first place. Now imagine doing this with something even smaller, a particle, one of the fundamental building blocks of the universe. The harder you try to measure exactly where it is, the less you know about where it's going. The more precisely you determine its velocity, the fuzzier its position becomes. This is the uncertainty principle, and it's not just a limitation of your tools. It's a fundamental property of reality itself. At the heart of this paradox lies an unsettling truth. The universe is not as precise or deterministic as it seems. In quantum mechanics, particles don't behave like tiny billiard balls rolling predictably along a table. Instead, they exist as waves of probability, smeared out across space and time with no definite position or velocity until you observe them. The uncertainty principle, formulated by physicist Werner Heisenberg, states that the more precisely you measure a particle's position, the less precisely you can know its momentum, and vice versa. It's not just a technical limitation, it's a feature of the universe's fabric, a boundary beyond which knowledge becomes fundamentally unknowable. Why is this so? Think of particles not as solid points, but as quantum waves. These waves describe the probabilities of where a particle might be or how fast it might be moving. To pinpoint a particle's position, you need a wave that's tightly packed in space. But the tighter the wave, the more spread out it becomes in momentum. On the other hand, if you want to measure the particle's velocity with precision, you need a wave that's spread out in space. You can't have both at the same time. The act of observing one aspect forces the other into a haze of uncertainty. This paradox feels deeply counterintuitive. In your everyday experience, you can measure both position and velocity with ease. You know where a car is and how fast it's moving. But at the quantum level, the rules are different. Particles don't have definite properties until you measure them. Before observation, they exist in a strange, indeterminate state, a superposition of possibilities, and your act of measuring doesn't just reveal their properties, it shapes them. You can't separate the observer from the observed. The uncertainty principle raises profound questions about the nature of reality. What does it mean for something to exist if its properties aren't definite until measured? Is the universe fundamentally fuzzy, or is there a deeper, hidden layer of reality that we simply can't access? Some physicists argue that uncertainty is a reflection of our incomplete understanding, a sign that we lack the tools to fully describe the quantum world. But others believe it's an intrinsic feature of the universe, a reminder that reality itself is probabilistic at its core. The paradox deepens when you consider the implications for determinism. In classical physics, the future unfolds predictably from the past if you know the initial conditions of a system, the positions and velocities of all its particles. You can calculate its future with perfect accuracy. But the uncertainty principle shatters this notion. If you can't measure initial conditions with precision, you can't predict the future with certainty. The universe, it turns out, is not a clockwork machine, but a dance of probabilities, where outcomes are shaped by chance as much as by cause and effect. And yet, the uncertainty principle isn't just a barrier to knowledge. It's also a source of wonder. It reveals a universe that is dynamic, unpredictable, and deeply interconnected. It's the reason particles can tunnel through barriers, appear in multiple places at once, and behave in ways that defy intuition. Without uncertainty, the quantum world would lose much of its magic, and the universe as we know it, including life itself, might not exist. But perhaps the most profound aspect of the uncertainty principle is what it teaches us about observation. In the quantum world, to observe is to interact, to influence, to change. Your act of looking doesn't just reveal reality, it helps create it. This challenges the very idea of objectivity, blurring the line between the observer and the observed. You're not just a passive spectator in the universe. You're an active participant in its unfolding story. So, as you ponder the uncertainty principle, let its paradoxical nature sink in. It's a reminder that the universe is far stranger than you can imagine, a place where knowledge has limits and reality resists being pinned down. And maybe that's the beauty of it. The uncertainty isn't a flaw, it's a feature. It invites you to let go of the need for absolute certainty, to embrace the mystery, and to marvel at the shimmering, elusive dance of existence itself. The paradox of life's purpose. You sit quietly, staring out at the vastness of the world around you. The sun rises, the seasons change, and the universe continues its unrelenting march through time. And yet, amid this cosmic expanse, a question whispers in your mind, tugging at your thoughts like an insistent thread. What's the point of it all? If life has no inherent meaning, no grand cosmic purpose, why do you feel such a deep, unshakable urge to find one? Why does the search for purpose feel so essential, so urgent, and yet, at times, so impossibly futile? This is the paradox of life's purpose, a puzzle as old as humanity itself. At first glance, the paradox seems straightforward. If life is the result of random processes, if the universe has no overarching plan or designer, then meaning is something we invent, not something we discover. And yet the need for meaning feels innate, as if it's hardwired into your very being. You want your life to matter, to connect to something bigger than yourself. But if the universe is indifferent, how can you reconcile this deeply human desire with a reality that may be inherently meaningless? For some, the answer lies in religion or spirituality. These frameworks provide a ready-made purpose. Life is part of a divine plan, a story written by something greater than you. But even here, the paradox persists. If purpose comes from an external source, God, the universe, fate, are you truly free to shape your own meaning? And if that external source doesn't exist, does the entire foundation of purpose collapse? Others turn to philosophy for answers, only to find that the paradox deepens. Existentialist thinkers like Jean-Paul Sartre argue that life has no inherent meaning, but this isn't a cause for despair. Instead, it's a call to action. You're free to create your own purpose. The burden and the beauty of existence lie in this freedom, but this solution raises its own questions. If purpose is something you invent, does it have any lasting significance? Or is it as fleeting and fragile as the life that creates it? Even science, which seeks to explain the mechanisms of life, struggles to address its meaning. Evolution tells you why you exist, to survive, to reproduce, but these explanations feel cold and unsatisfying. You aren't just a machine following biological imperatives. You feel, dream, and yearn for something more. Science can tell you how life came to be, but it can't tell you why it feels so profoundly meaningful, or why the lack of meaning is so deeply unsettling. The paradox becomes even more personal when you consider how much of your life is spent chasing purpose. You pursue careers, relationships, achievements, and passions, hoping they'll give your life direction. And yet, every time you grasp one goal, another appears on the horizon. The search for purpose is endless, a journey without a destination. Why does it feel so necessary to find meaning, even when it seems elusive or impossible? Perhaps the answer lies in the paradox itself. The search for purpose isn't something to solve, but something to live. The act of seeking, questioning, and striving is what gives life its richness and depth. If life had a preordained meaning, there would be no need for discovery, no space for creativity, no reason to ask, why? The paradox forces you to confront the tension between a universe that may be indifferent and a mind that refuses to accept indifference. It's in this tension that life's most profound moments are born. The paradox of life's purpose also invites you to reflect on what meaning truly is. Is it something grand and eternal, or can it be found in the smallest moments? A kind word, a shared laugh, the beauty of a sunset? Maybe the purpose of life isn't a single, universal answer, but a collection of individual meanings, stitched together by the experiences and connections that make your life uniquely yours. So, as you sit with this paradox, let it challenge you. Let it remind you that life's questions are often more important than its answers. The search for purpose may never be resolved, but it's the search itself that gives your existence its texture and vitality. The paradox isn't a barrier to meaning, it's the source of it. In the end, the paradox of life's purpose leaves you with a choice. You can see it as a contradiction, a flaw in the fabric of existence, or you can see it as an invitation to create, to explore, to live fully in the face of uncertainty. And perhaps the greatest gift of the paradox is this: it doesn't give you the meaning of life. It gives you the freedom to find your own. The wave-particle duality. Paradox. Imagine a beam of light streaming through a window, illuminating the room with a warm glow. To your eyes, it seems simple enough, just light, but hidden within that familiar radiance is one of the most mind-bending paradoxes of physics. Light, and indeed all matter, behaves both as a particle and as a wave. It's not one or the other. It's both. And this duality defies everything you think you know about how reality works. To understand the paradox, let's start with particles. Particles are discrete. They have a specific location and can be counted, like marbles in a jar. Waves, on the other hand, are spread out and continuous, like ripples in a pond. You wouldn't confuse the two until you encounter light. When you shine light through a double-slit experiment, you see something extraordinary. Instead of forming two distinct patterns, as particles would, the light creates an interference pattern, like overlapping ripples from two stones dropped in water. This is wave behavior, clear as day. But here's where the paradox takes hold. When you place a detector at the slits to observe which slit the light passes through, the interference pattern disappears. Suddenly, the light behaves like particles again, creating two distinct lines. The act of observing changes its behavior. It's as if the light knows you're watching and adjusts accordingly. How can something behave as a wave one moment and a particle the next? It's not just light that plays by these strange rules. Electrons, protons, even entire atoms exhibit the same dual nature. When left undisturbed, they act like waves, spread out across space in a cloud of probabilities. But the moment you observe them, they collapse into particles with definite positions and properties. Reality itself seems to shift depending on how you look at it. This duality raises profound questions. What is light? What is matter? Is a particle really a particle, or is it something else entirely? A wave of potential that only becomes a particle when observed? And if observation changes reality, what does that say about the role of the observer? Are you, in some strange way, shaping the very nature of existence simply by looking at it? Physicists have tried to make sense of this paradox for over a century. Quantum mechanics, the framework that describes the behavior of particles and waves, explains how wave-particle duality works, but not why. According to the mathematical formalism, particles exist as wave functions, mathematical descriptions of probabilities until they're measured. But why does measurement collapse the wave function? Why does reality seem to care whether you're watching or not? Some interpretations suggest that particles aren't either waves or particles, but something entirely different, something your mind struggles to grasp. Others, like the many worlds interpretation, argue that every possible outcome of a wave function happens, but in separate, parallel universes. In one universe, the particle passes through one slit. In another, it passes through the other. You experience just one outcome, but all outcomes exist simultaneously across countless realities. But even these interpretations leave the paradox unresolved. Why does reality have this dual nature at all? Why does the universe, which feels so concrete and predictable on a macroscopic scale, become so strange and fluid at its smallest levels? Wave-particle duality isn't just a quirk of quantum mechanics. It's a window into the fundamentally paradoxical nature of reality. The implications are staggering. Wave-particle duality suggests that reality isn't fixed or solid. It's dynamic, shifting, and interconnected. The universe isn't made of tiny, indivisible pieces, but of probabilities and relationships, a web of potential that only crystallizes into things when observed. And if observation plays such a central role, then your place in the universe isn't passive. You're not just a spectator, you're a participant in shaping the very fabric of existence. So, as you contemplate the wave-particle duality paradox, let its strangeness sink in. It's a reminder that the universe is far more mysterious and wondrous than it appears. The light streaming through your window isn't just light, it's a paradox, a dance between waves and particles, between certainty and possibility. It challenges you to question the nature of reality and your role within it. Perhaps the greatest lesson of the wave-particle duality paradox is this: reality doesn't conform to your expectations. It defies your logic, your categories, your need for certainty, and yet, in that defiance, it reveals something profound, that the universe is not a puzzle to be solved, but a mystery to be lived, a paradox that invites you to marvel at the beauty of the unknown. The simulated reality. Paradox. Take a moment to look around you. The objects in the room, the sound of your breath, even the thoughts in your mind. Everything feels real, solid, unquestionable. But then a thought slithers into your consciousness, unsettling in its simplicity. What if none of this is real? What if everything you see, touch, and feel is part of an elaborate simulation. And here's the kicker. If you are living in a simulation, how could you ever prove it? This is the simulated reality paradox, a question that shakes the very foundations of existence and plunges you into a rabbit hole of infinite regression. The idea isn't new. Philosophers like Descartes wrestled with the notion of a deceptive reality centuries ago, pondering whether an evil demon could be tricking us into believing in a false world. But in modern times, this thought experiment has taken on a technological edge. With the rise of virtual reality, artificial intelligence, and increasingly sophisticated simulations, it's no longer just a question of philosophy. It's a question of science. Could a sufficiently advanced civilization create a simulation so perfect that its inhabitants wouldn't even know they were simulated? And if they could, what are the chances that you are part of one? The odds, as it turns out, might not be in your favor. Philosopher Nick Bostrom famously proposed the simulation hypothesis, arguing that if any advanced civilization could create simulations indistinguishable from reality, they would likely create many, perhaps billions, of such simulations. Statistically, it would be far more likely for you to be living in one of these simulated realities than in the base reality, the original, unsimulated world. The logic is chilling. If it's possible to simulate reality, then you almost certainly are in a simulation. But how would you know? That's the paradox. A perfect simulation, by definition, would be indistinguishable from reality. Every sensation, every memory, every law of physics would feel authentic. Even your doubts about the simulation could be part of the simulation itself. Trying to prove you're in a simulation would be like a character in a video game trying to see the player behind the screen. It's a perspective you simply can't access. And yet, there are cracks in the facade, tiny glitches that make you wonder. The strangeness of quantum mechanics, with its probabilistic nature and observer effects, feels eerily like the behavior of a computer program running simulations. The limits of the speed of light and the finite nature of the universe could be constraints of computational power. Even the uncanny patterns in mathematics, like the seemingly arbitrary constants that govern the cosmos, could be clues left by the programmers, or just artifacts of a simulated system. But here's where the paradox deepens. If we are in a simulation, then what about the beings who created it? Are they part of another simulation? And if so, who created them? This leads to an infinite regression, a never-ending chain of simulated worlds within simulated worlds. Somewhere, there might be a base reality, but how could you ever be sure it's not just another simulation? The simulated reality paradox isn't just a theoretical puzzle. It's a challenge to your very sense of self. If your world is simulated, does that make you less real? Are your thoughts, emotions, and experiences any less meaningful if they're lines of code rather than neurons firing? Or does it even matter? After all, if the simulation feels real to you, isn't that enough? Some find comfort in this idea, seeing it as a modern form of spirituality. If we're in a simulation, then there's a creator, intelligent beings who designed our world. This could mean our lives have purpose, even if that purpose is unknowable. Others find the idea deeply unsettling, a reminder that we might be pawns in a game we don't understand, subject to the whims of programmers who could delete us with a keystroke. But perhaps the paradox is more about perspective than proof. Whether you're in a simulation or not, the world you experience is your reality. The relationships you build, the beauty you witness, the choices you make, all of these are real to you. no matter their ultimate origin. The paradox invites you to embrace the mystery, to live fully within a reality that might be simulated, but is no less meaningful for it. So, the next time you wonder if your world is real, let the simulated reality paradox remind you of something profound. Reality, simulated or not, is what you make of it. And perhaps the greatest gift of the paradox is this. In a universe that might be programmed, your experience is the only thing that truly belongs to you. Whether it's code or cosmic truth, it's your story, your reality, and that makes it real enough. The nothingness paradox. Close your eyes and imagine nothing, not darkness, not emptiness, just pure, absolute nothingness. No space, no time, no matter, no energy. It's an impossible task because your mind is wired to think in terms of something. Yet the question remains, if once there was truly nothing, how did something, our universe, existence itself, come to be? This is the nothingness paradox, a riddle that challenges the very fabric of reason and shakes the foundations of how you understand reality. At first glance, the paradox seems straightforward. From nothing, nothing comes. It's a principle as old as philosophy itself, championed by thinkers like Parmenides, who argued that non-existence cannot produce existence. And yet, here you are. The universe exists, brimming with stars, planets, and life. Somehow, the impossible happened. But how? Did something always exist, or did the universe emerge from nothing? Either answer feels unsatisfying, leaving you trapped in the paradox. If something has always existed, the concept of a beginning dissolves. Time stretches infinitely backward, an eternal thread with no starting point. But this creates its own set of problems. How can something exist without a cause? How can there be no ultimate origin? Your mind craves an explanation, a reason for why things are the way they are, but infinity offers none. Instead, it loops endlessly, leaving you to wrestle with the unsettling possibility that there may be no beginning, just existence, uncaused and eternal. On the other hand, if the universe truly came from nothing, the paradox intensifies. How can nothingness, devoid of energy, matter, or even potential, give rise to something as vast and intricate as the cosmos? The laws of physics as you know them demand a cause for every effect. But in this case, there was no cause, just a sudden, inexplicable leap from non-existence to existence. The universe, it seems, broke its own rules to bring itself into being. Modern science offers theories, but they only deepen the mystery. The Big Bang Theory describes the universe's expansion from an unimaginably dense point, but it says nothing about what caused it or what came before. Quantum mechanics suggests that particles can spontaneously appear and disappear in a vacuum, seemingly emerging from nothing. But even a quantum vacuum isn't truly nothing. It's a seething field of energy governed by physical laws. Where did those laws come from? Why do they exist at all? Some physicists propose that the universe could have arisen from quantum fluctuations in a kind of meta-nothingness, a realm beyond space and time. Others suggest the universe might be a mathematical structure, existing not because it was created, but because it simply must exist, like the truths of mathematics themselves. These ideas are fascinating, but they push the question further back. Where did the meta-nothingness or mathematical inevitability come from? The paradox doesn't disappear. It just shifts. Philosophy, too, grapples with the nothingness paradox. Some thinkers argue that the very concept of nothing is flawed. To speak of nothing is to make it something, a concept an idea, a placeholder in your mind. True nothingness, they suggest, might be so alien to your understanding that you can't even conceive of it. Others propose that existence is the default state, that something is inevitable because nothing is inherently unstable or meaningless. And yet, the paradox persists. Whether you frame it in terms of science, philosophy, or metaphysics, the transition from nothing to something remains as enigmatic as ever. It's a question that defies easy answers, that pushes you to the edge of what you can know and leaves you staring into the void. But perhaps the paradox isn't meant to be solved. Maybe it's a reminder of the profound mystery of existence, a mystery that you're a part of, even if you can't fully understand it. After all, the fact that you're here, pondering the nature of nothingness, is extraordinary in itself. The paradox invites you to marvel at the sheer improbability of being, to see the universe not as a problem to decode, but as a wonder to experience. So, as you sit with the nothingness paradox, let it open your mind to the vastness of the unknown. Whether the universe came from nothing or has always been, the simple fact that it is, that you are, should be enough to leave you awestruck. The paradox doesn't diminish existence. It magnifies it, showing you that even the simplest question, why is there something rather than nothing, contains a depth and beauty that will never be exhausted. And maybe that's the point. The transition from nothing to something isn't just a mystery. It's the ultimate gift, a doorway to wonder, a paradox that breathes life into the very act of asking why. The measurement problem. Picture a tiny particle, so small you can't see it, existing in a strange, blurry state. It's not here or there. It's everywhere it could possibly be, a swirling cloud of probabilities. But the moment you try to measure it, everything changes. The cloud collapses, the particle chooses a definite state, and the act of observing seems to alter the very nature of reality itself. This is the measurement problem, one of the most perplexing mysteries in quantum mechanics. It doesn't just challenge your understanding of the universe, it blurs the boundary between reality and perception, raising the unsettling question: does the universe exist as it is, or only as you observe it? At the heart of the measurement problem lies the quantum wave function, a mathematical tool that describes the probabilities of where a particle might be, how fast it's moving, or what state it's in. Before you measure it, the particle exists in superposition, a strange state where all possibilities coexist. But the instant you measure it, the wave function collapses, and the particle locks into a single outcome. Why does this happen? Why does the act of measurement seem to choose reality? This paradox forces you to rethink the very nature of observation. In classical physics, observing something doesn't change its state. A tree in a forest exists whether or not anyone is there to see it. But in the quantum world, observation isn't passive, it's interactive. When you measure a particle, you're not just observing it, you're participating in its existence, forcing it to decide on a definite state. It's as if reality itself responds to your gaze. The implications are profound and unsettling. If particles only choose a state when observed, what does that say about the universe when no one is looking? Is the moon there when you're not observing it? Does reality exist independently of observation, or is it fundamentally tied to the act of being perceived? Physicists and philosophers have proposed various interpretations to make sense of the measurement problem, but none are fully satisfying. The Copenhagen interpretation, one of the earliest and most widely taught, suggests that the wave function's collapse is an intrinsic part of quantum mechanics. Reality, it claims, is probabilistic until you measure it. But this raises more questions than it answers. What exactly constitutes a measurement? Does it require a conscious observer, or is any interaction enough to collapse the wave function? Other interpretations take the mystery even further. The many worlds interpretation argues that the wave function never collapses. Instead, every possible outcome of a measurement occurs, but in separate, parallel universes. When you measure the particle, you see one result, but countless other versions of you exist in alternate realities, observing all the other possibilities. It's a seductive idea, but it replaces the collapse mystery with an even stranger one. If every possibility happens, why do you experience only one? Then there's the relational interpretation, which suggests that the state of a quantum system isn't absolute, but depends on its relationship to the observer. In this view, reality isn't a fixed objective thing, it's fluid, changing based on interactions. What's real for you might not be real for someone else, and the universe becomes a web of relationships rather than a collection of independent objects. The measurement problem also invites deeper philosophical questions. If observation changes reality, does that mean the observer plays a fundamental role in shaping the universe? Are you not just a passive bystander, but an active participant in the unfolding story of existence? And if reality depends on observation, what does that say about your perception of the world? Is everything you experience a construct, a product of the act of observing? But perhaps the most profound aspect of the measurement problem is the way it challenges your assumptions about reality itself. You're accustomed to thinking of the world as solid, predictable, and independent of you. But quantum mechanics paints a picture of a universe that's probabilistic, interconnected, and deeply tied to your presence in it. Reality isn't fixed, it's dynamic, a constantly shifting interplay between the observer and the observed. As you ponder the measurement problem, let its paradoxical nature sink in. It's a reminder that the universe is stranger than you can imagine, a place where the act of looking doesn't just reveal reality, but creates it. The problem isn't just a question of physics, it's a question of existence, perception, and the delicate dance between the known and the unknown. So, the next time you gaze at the world around you, remember this: what you see might not be the whole story. Reality is more fluid, more mysterious, and more connected to you than it seems. The measurement problem isn't just a puzzle to solve, it's an invitation to marvel at the profound mystery of being, where the boundary between what is real and what is observed dissolves into the infinite possibilities of the quantum world. The paradox of memory. Think of a cherished memory, something that feels etched into the very core of who you are, a childhood adventure, a first love, a pivotal moment. You hold it close, confident in its authenticity, certain that it happened just as you remember. But here's the unsettling truth. Every time you recall that memory, you're not retrieving it like a file from a cabinet. You're rewriting it, tweaking it, altering it in subtle, imperceptible ways. This is the paradox of memory, a riddle that questions the reliability of your past and shakes the foundation of how you understand yourself. Memory feels like a stable bridge connecting you to the past, yet neuroscience tells a different story. Every time you remember something, your brain reactivates the neural pathways associated with that memory. This process, called reconsolidation, is not perfect. The memory isn't a snapshot frozen in time. It's more like a clay figure, reshaped each time you touch it. Details shift, gaps fill in, and the emotional tone might change. The more you revisit the memory, the more it evolves, until what you hold in your mind is as much a story as it is a fact. This raises a troubling question. If memories are so malleable, how can you trust them? What if the moments you hold most dear, the ones that define you, aren't as accurate as you think? Your sense of self, your identity, is built on these memories. They shape your beliefs, your choices, your understanding of the world. But if they're unreliable, what does that say about the version of you that exists today? The paradox deepens when you realize how easily memories can be influenced. Studies have shown that simply suggesting a false detail can implant it into someone's recollection, making them believe it's real. Entire fabricated memories, like meeting someone who wasn't there or experiencing an event that never happened, can feel as vivid and true as genuine ones. The mind doesn't store the past as it was. It stores the past as it's perceived, and perception is always fluid, always subject to distortion. This paradox also forces you to confront the emotional weight of memory. The way you recall an experience isn't just about accuracy, it's about meaning. The feelings attached to a memory can amplify or dull over time, depending on your present state of mind. A painful moment might soften with years of perspective, or a minor slight might grow into a monumental grievance. The memory itself changes, shaped as much by who you are now as by who you were then. But if memory is unreliable, why does it feel so real? Why do you trust it so deeply, even when you know it's fallible? The answer lies in the way your brain constructs reality. Memory isn't just a record of the past, it's a tool for survival. By remembering, you learn from your experiences, predict future outcomes, and navigate the complexities of life. The brain's priority isn't accuracy, it's adaptability. It shapes memories to serve the present, even if that means rewriting the past. And yet, the paradox doesn't stop there. If memory is fluid, does that mean the past is too? After all, the only version of the past you have access to is the one your mind reconstructs in the present. The objective reality of what happened might be forever out of reach, leaving you with a past that exists more in perception than in fact. But perhaps this isn't a flaw, it's a feature. The paradox of memory reminds you that the past isn't just something that happened to you, it's something you continually create. It's a dynamic, living thing, shaped by your experiences, emotions, and understanding. And while this means memory isn't perfect, it also means it's deeply personal. Your memories aren't just records, they're reflections of who you are, evolving as you do. So, as you sit with the paradox of memory, let it challenge your assumptions about the past. Accept that what you remember might not be the whole truth, but don't let that diminish its meaning. Memory isn't about capturing reality. It's about making sense of it, giving it purpose, and weaving it into the story of your life. In the end, the paradox of memory isn't just a question of trust. It's a testament to the resilience of the human mind. Even if the details blur, the essence remains. Your memories, imperfect as they are still yours. They're the thread that connects you to your past, shapes your present, and guides your future. And maybe that's all they need to be. The arrow of time paradox. Picture an arrow soaring through the air, its path clear and unwavering, moving forward with certainty. Now imagine time as that arrow, carrying you relentlessly from the past through the present and into the future. You can remember yesterday, but never tomorrow. You can affect what's to come, but never what has already happened. But here's the paradox. Why does time move in one direction at all? The fundamental laws of physics, the equations that govern the universe, don't demand it. They work just as well whether time flows forward or backward. So why do you experience time as a one-way journey, an arrow that never reverses? At the heart of this paradox lies a contradiction between how you perceive time and how the universe operates. The laws of physics are time-symmetric. Whether you watch a ball rolling across a table or rewind the tape so it rolls backward, the underlying equations remain valid. Nothing in these laws explicitly forbids time from flowing in reverse. And yet, that's not how reality feels. You never see spilled milk unspill itself or shattered glass reform into a pristine whole. Time, in your experience, always marches forward, dragging the universe along with it. The explanation most often invoked to resolve this paradox is entropy, the measure of disorder in a system. According to the second law of thermodynamics, entropy in a closed system tends to increase over time. A neat, ordered state will inevitably give way to chaos. This law provides a direction, a thermodynamic arrow of time. Spilled milk doesn't unspill because doing so would decrease entropy, violating this fundamental principle. But this explanation raises an even deeper question. Why did the universe start in such a low entropy state to begin with? Why was everything so improbably ordered at the beginning of time? This question plunges you into the realm of cosmology. The early universe, just after the Big Bang, was astonishingly uniform and low in entropy, a state so unlikely it's hard to comprehend. From this improbably tidy beginning, the universe has been unraveling ever since, stars burning their fuel, galaxies spreading apart, and systems moving toward disorder. But why was the universe set up this way? Was it a fluke, a cosmic accident? Or is there some deeper reason for this initial state? Something that ties the arrow of time to the very fabric of existence. The paradox grows stranger when you consider the role of perception. Your sense of time's flow isn't just about physics, it's also about how your brain processes reality. Memory plays a critical role. You remember the past, but not the future, creating the illusion of time moving forward. But why is your memory tied to this forward flow? If the laws of physics allow time to run backward, could there exist beings or systems that remember the future instead of the past? Would their reality feel as natural to them as yours does to you? Some physicists suggest that the arrow of time might not be as universal as it seems. In certain theoretical frameworks, time could flow differently in different parts of the universe, or even loop back on itself in certain conditions. These ideas, while speculative, challenge the assumption that time's forward march is a fundamental feature of reality. What if the arrow of time isn't a law, but a perspective, a consequence of how you, as an observer, interact with the universe? Others propose that time itself might be an emergent phenomenon, not a fundamental property of the universe, but a byproduct of deeper, timeless laws. In this view, what you perceive as the flow of time could be an illusion, a construct of your mind making sense of a reality that doesn't actually move. It's a disorienting idea, one that forces you to question the very nature of existence. The arrow of time. Paradox ultimately asks you to confront the mystery of time itself. Why does it feel like an unstoppable current, carrying you forward whether you like it or not? Why does the universe unfold with such irreversibility when the underlying laws say it doesn't have to? And perhaps most unsettling of all, What would reality look like if time didn't have a direction? As you ponder these questions, let the paradox remind you of something extraordinary. Your experience of time, as ordinary as it seems, is a profound mystery. The arrow that carries you forward from birth to death, from today to tomorrow, is a gift and a challenge, a fleeting chance to make sense of the moments as they pass. Whether time flows like an arrow, loops like a spiral, or emerges from something beyond your understanding, the paradox invites you to savor its passing, because even if the direction of time is an illusion, the moments you experience along the way are undeniably real. The mind-body paradox. Close your eyes and think about your thoughts, your emotions, your sense of self. They feel intangible, ethereal, something you can't weigh or touch. Yet these non-physical experiences are somehow tied to your body, a complex network of neurons, muscles, and chemical processes. When you stub your toe, the pain isn't just in your foot, it's in your mind. When you feel anxious, your heart races and your palms sweat. But how does this happen? How does something immaterial, like the mind, influence something physical, like the body? And how does the physical brain give rise to the subjective experience of consciousness? This is the mind-body paradox, a question that cuts to the heart of what it means to be human. The paradox begins with a fundamental duality: the mind, which seems non-physical, and the body, which is undeniably physical. Your brain operates according to the laws of biology and physics. It's a machine made of matter, governed by chemical reactions and electrical impulses. But your mind, your thoughts, memories, emotions, feels like something entirely different. You can't point to a thought or way of feeling. They exist in a realm that seems separate from the physical. How can these two realms, one tangible, one intangible, interact? Philosophers have wrestled with this question for centuries, tracing the debate back to thinkers like René Descartes. Descartes proposed that the mind and body are distinct substances. The body is material, subject to the laws of physics, while the mind is immaterial, existing beyond physical constraints. He argued that these two interact through the pineal gland, a tiny structure in the brain. But his explanation only deepened the paradox. If the mind is non-physical, how could it influence a physical object like the brain? And if it can't, how do your thoughts move your body? Modern science hasn't solved the paradox. It's only added layers to the mystery. Neuroscience has shown that mental states correlate with brain activity. When you feel joy, specific regions of your brain light up. When you think of a memory, neurons fire in patterns associated with that thought. This suggests that the mind arises from the brain, that your sense of self is a product of physical processes. But this explanation raises more questions than it answers. How do physical processes generate subjective experience? Why does firing neurons result in feeling something rather than just producing behavior? This is the hard problem of consciousness, a puzzle that lies at the heart of the mind-body paradox. You can explain the brain's mechanics, how signals travel through neurons, how synapses transmit information. But none of this explains why it feels like anything to be you. Why doesn't the brain work like a computer, processing inputs and outputs without awareness? Where does the richness of subjective experience, the vividness of colors, the sharpness of pain, the warmth of love come from? Some theories attempt to resolve the paradox by rejecting duality altogether. Physicalists argue that the mind is the brain, that consciousness is nothing more than the activity of neurons. From this perspective, your thoughts and feelings are byproducts of physical processes, like steam rising from boiling water. But this explanation feels incomplete. It doesn't explain why those physical processes should give rise to subjective experience at all. Why should a collection of atoms produce a mind? Others suggest that the mind and body aren't separate, but are two aspects of the same underlying reality. This idea, known as dual aspect theory, posits that the physical and mental are different ways of perceiving the same thing. Your brain, viewed from the outside, is a network of neurons. Viewed from the inside, it's your mind. But this doesn't explain how the two aspects connect or why they exist in the first place. The paradox also raises profound philosophical and existential questions. If your mind and body are separate, which one is the real you? If they're the same, why does your experience feel so divided? Your mind commanding your body influencing your mind? And if the mind is purely physical, what does that mean for free will? Are your thoughts and choices just the inevitable result of chemical reactions, leaving no room for true autonomy? The mind-body paradox ultimately forces you to confront the mystery of existence itself. What are you? Are you your body, a collection of cells and systems? Are you your mind, a stream of thoughts and sensations? Or are you something more, a synthesis of the two, something that transcends the physical and the immaterial? As you ponder this paradox, let it remind you of the wonder of being, the fact that your mind and body interact at all, that your thoughts can move your limbs, that your feelings can shape your health, is extraordinary. The paradox doesn't diminish your experience. It deepens it, revealing the complexity and interconnectedness of what it means to be alive. Maybe the mind-body paradox isn't meant to be solved. Maybe it's an invitation to explore, to reflect, to marvel at the strange and beautiful union of the tangible and the intangible. After all, you are both mind and body, thought and flesh, a walking, breathing paradox in a universe full of mysteries, and that, perhaps, is the greatest wonder of all. The black hole. Information. Paradox. Imagine standing at the edge of a black hole, the most enigmatic and terrifying object in the universe. Its gravity is so immense that not even light can escape its pull, and anything that crosses its event horizon, the point of no return, disappears from view forever. But what happens to the information about what falls in? Is it truly lost, erased from the universe? Physics tells you that information, the fundamental building blocks of reality, can't simply vanish. Yet black holes seem to defy this rule, swallowing both matter and its information without a trace. This is the black hole information paradox, a puzzle that pits the laws of quantum mechanics against the theory of general relativity, leaving reality itself hanging in the balance. To understand the paradox, you must first grasp why information matters so much. In physics, information isn't just about words or data. It's the unique arrangement of particles and energy that defines the state of a system. If you burn a book, for example, the paper and ink are destroyed, but the information contained in the book isn't truly lost. It's encoded in the smoke, heat, and ash. The principle of information conservation is a cornerstone of quantum mechanics. No matter what transformations occur, the information must persist, even if it's scattered or hidden. Black holes, however, seem to break this rule. When an object falls into a black hole, it's stretched, compressed, and eventually torn apart by the intense gravitational forces, a process so extreme it's as if the information about that object is obliterated. Once it crosses the event horizon, the information appears to vanish entirely, lost to the singularity at the black hole's core. If the black hole evaporates over time, as Stephen Hawking famously showed through Hawking radiation, the paradox deepens. The black hole emits radiation as it shrinks, but this radiation is random, carrying no trace of the information that fell in. When the black hole eventually disappears, so does the information it once contained. Or does it? This apparent loss of information creates a clash between two of the most successful theories in physics. General relativity, which describes black holes, tells you that anything crossing the event horizon is gone forever, its details irretrievably lost. Quantum mechanics, on the other hand, insists that information cannot be destroyed. Both theories are incredibly well tested, yet they seem irreconcilable in the face of this paradox. If information is truly lost in black holes, it would upend the principles of quantum mechanics, undermining the very foundation of how you understand the universe. Physicists have wrestled with this paradox for decades, proposing a variety of potential solutions, each more mind-bending than the last. One idea suggests that information isn't lost, but is somehow encoded in the Hawking radiation emitted by the black hole. This radiation, though seemingly random, might carry subtle patterns that preserve the information, albeit in a highly scrambled form. If true, it would mean that black holes act like cosmic recyclers, transforming information rather than erasing it. Another hypothesis proposes that information is stored on the event horizon itself. The holographic principle suggests that the surface of a black hole contains all the information about what falls in, encoded in 2 dimensions, like a hologram. This idea challenges your understanding of reality, implying that the universe itself might be a hologram, with 3-dimensional space emerging from underlying 2-dimensional data. And then there's the possibility that black holes are gateways to parallel universes. Perhaps the information isn't lost, but transferred to another reality, inaccessible to you, but preserved in some cosmic ledger. This raises profound questions about the nature of existence and whether our universe is just one of many, connected through the mysterious mechanisms of black holes. The black hole. Information paradox doesn't just challenge your understanding of physics, it forces you to confront the limits of knowledge itself. What is reality if its most fundamental laws seem to contradict each other? Are black holes revealing a deeper layer of the universe, one where quantum mechanics and relativity merge into a unified theory? Or are they exposing the edges of human comprehension, the places where even the sharpest minds can only guess? As you ponder this paradox, let its enormity sink in. Black holes, those cosmic enigmas, aren't just devourers of matter. They're keepers of secrets, gateways to mysteries that lie at the heart of existence. Whether the information is preserved, encoded, or truly lost, the black hole information paradox reminds you of the profound complexity of the universe, a place where the rules you thought were absolute begin to bend and blur. And maybe that's the lesson of the paradox. Not every answer is within reach, and not every question is meant to be solved. Black holes challenge you to explore, to imagine, and to wonder. They remind you that the universe is a place of infinite depth, where even the darkest mysteries hold a light of discovery, waiting for you to peer into the void and ask, what lies beyond? The paradox of death. You're alive right now, reading these words, conscious of the world around you and your place within it. But someday, that will change. Your heart will stop, your body will cease to function, and the vibrant inner world of your thoughts and feelings will vanish. Or will it? The question of what happens after death has haunted humanity for as long as we've been able to ask it. It's not just about the fear of dying, it's about the mystery of what comes next. Is death an end, a transition, or something else entirely? This is the paradox of death, a riddle that forces you to confront the boundaries of existence and the ultimate question: what happens when you are no longer here? The paradox begins with the fundamental mystery of consciousness. You know you exist because you're aware, thinking, feeling, experiencing. But what happens to that awareness when the body that sustains it fails? Does it simply disappear like a flame extinguished? Or does it persist in some form, detached from the physical shell that housed it? Science can explain what happens to the body after death. It decomposes, returning to the earth. But the fate of the mind, the self, remains an enigma. Some argue that death is the ultimate end. Consciousness, they say, arises from the brain, a complex network of neurons firing in intricate patterns. When the brain stops functioning, so does the mind. In this view, death is non-existence, a state not unlike the one before you were born. But here's where the paradox emerges. If death is the absence of consciousness, how can you even conceive of it? Your mind recoils at the idea of non-existence because it's an experience you can't experience. You can imagine pain, joy, or even the vast emptiness of space, but not the complete absence of awareness. Others find solace in the idea that consciousness doesn't end with death. Many spiritual traditions teach that some part of you, your soul, essence, or energy, transcends the body and continues to exist. Whether it's an afterlife, reincarnation, or merging with a greater cosmic whole, these beliefs offer a way to see death not as an end, but as a transformation. But even these ideas raise questions. If the self persists, what is it like? Does it retain memory, personality, or identity? Or does it dissolve into something unrecognizable, losing the you that you cling to so dearly? The paradox also challenges the very concept of time. Death feels like a future event, a point on the timeline of your life. But what if time itself ceases to exist when you die? Some philosophers and physicists suggest that your perception of time is tied to your consciousness. Without awareness, there's no before or after, no past or future, just an eternal absence. This idea defies your every instinct, making death seem at once inconceivable and inevitable. Even modern science, with all its advances, offers no clear answers. Near-death experiences, where people report tunnels of light, out-of-body sensations, or feelings of peace, hint at the possibility of something beyond. But are these glimpses of an afterlife, or are they simply the brain's way of coping with the trauma of dying? Quantum physics has also been invoked, with some theorists speculating that consciousness might be a fundamental aspect of the universe, not confined to the brain. But these ideas remain speculative, offering tantalizing possibilities without resolution. The paradox of death ultimately forces you to confront your own limits. You spend your life seeking certainty, understanding, and control, but death is the one thing you can never fully grasp. It is the ultimate unknown, a mirror reflecting your deepest fears, hopes, and questions. And yet, it is also the great equalizer, the one experience shared by all living things, connecting you to the vast tapestry of existence. Perhaps the paradox isn't meant to be solved. Maybe its purpose is to remind you of the fragility and preciousness of life, the fact that your time is finite, that it will one day come to an end, makes each moment you have all the more meaningful. Death may be a mystery, but it's also a teacher, urging you to live fully, love deeply, and embrace the wonder of being. So, as you ponder the paradox of death, let it guide you not to despair, but to appreciation, whether death is an end, a beginning, or something beyond your comprehension. It's a part of the story that makes life what it is. The mystery of non-existence may never be unraveled, but the beauty of existence, of this moment, right now, is something you can hold on to. And in that, perhaps, lies the greatest answer of all: the bootstrap paradox. Imagine holding a book, one filled with groundbreaking knowledge or revolutionary ideas. Now picture yourself traveling back in time and handing that book to a younger version of its supposed author, who then uses it as inspiration to write the very same book. Here's the twist. Where did the book's knowledge originate? It didn't come from the author, it came from the future, but it couldn't exist in the future without first being written in the past. This is the bootstrap paradox, a mind-bending puzzle that defies the linear flow of cause and effect and leaves you questioning the very fabric of reality. The paradox takes its name from the phrase pulling oneself up by one's bootstraps, an absurdly impossible act. In this case, the impossibility lies in the self-originating nature of the object or knowledge. It exists, but it has no clear point of creation. The object seems to loop endlessly in time, passed from the future to the past and back again, existing without an origin. How can something exist without ever having been created? It's a concept so strange, it feels like reality itself folding in on itself. Take a simple example. A time traveler from the future goes back in time and teaches a young Beethoven how to compose his symphonies. The young Beethoven grows up to write those symphonies, which are then studied in the future by the very time traveler who goes back to teach him. In this loop, Beethoven's genius doesn't originate from anywhere. It's recycled between the past and the future. The cause becomes the effect, and the effect becomes a cause, creating a closed loop with no beginning or end. But if there's no starting point, how does the loop exist at all? The bootstrap paradox isn't just a quirky thought experiment. It raises profound questions about the nature of time, causality, and existence. Time, as you experience it, feels linear. Events flow from the past to the present to the future in an unbroken sequence. But the paradox suggests that time isn't so straightforward. If causality can loop back on itself, does that mean time is more like a tangled web, with events influencing each other in nonlinear ways? This paradox also forces you to question the idea of creation itself. In a bootstrap scenario, the object or knowledge seems to exist independently of any origin. It's self-sustaining, defying the logic that everything must come from something. Does this mean there are things in the universe that don't require a cause? Or does it point to deeper laws of time and existence that you can't yet understand? Science fiction loves to explore the bootstrap paradox, weaving it into stories of time travel and alternate realities. From objects like a time traveler's watch that appears in the past and future without ever being made, to knowledge that reshapes history without ever being discovered, these tales highlight the paradox's mind-bending implications. But even in fiction, the paradox remains unresolved, a puzzle that defies explanation. Physics, too, struggles to make sense of the bootstrap paradox. Some interpretations of quantum mechanics suggest that events in the past and future might influence each other in subtle ways, creating feedback loops that resemble the paradox. Theoretical constructs like closed time-like curves allow for the possibility of time loops, where cause and effect are intertwined. But even these ideas don't explain how an object or piece of knowledge can exist without an origin. The paradox also raises questions about free will. If you're part of a bootstrap loop, are your actions predetermined by the loop itself? If Beethoven writes his symphonies because he was taught by a time traveler, can he truly claim them as his own? Or is he simply following a script written by the paradox? The bootstrap paradox blurs the line between choice and inevitability, leaving you to wonder how much control you really have over your life and your future. But perhaps the most unsettling aspect of the paradox is its implication that reality itself might be incomplete. If something can exist without an origin, what does that say about the nature of existence? Are there parts of reality that simply are, with no need for explanation? Or is the paradox a sign that your understanding of time and causality is fundamentally flawed? As you ponder the bootstrap paradox, let its strangeness sink in. It's a reminder that the universe is far more mysterious than it appears, a place where the rules you take for granted might break down under the weight of deeper truths. The paradox doesn't offer easy answers, but it does invite you to marvel at the complexity of existence and to question the very fabric of reality. Perhaps the paradox's greatest lesson is this: the search for origins, whether of objects, knowledge, or existence itself, may lead you in circles. But those circles aren't failures. They're invitations to explore, to wonder, and to embrace the profound mystery of a universe where even the simplest question, "Where did this come from?" can spiral into infinite possibility. The multiverse paradox. Imagine looking up at the night sky, feeling the vastness of the cosmos pressing down on you. Now imagine that this universe, the one you know, the one that holds everything you've ever experienced, is just one among countless others. Parallel universes, each with its own rules, histories, and realities, could stretch infinitely beyond your perception. It's a staggering thought, but it comes with a tantalizing question. If these other universes exist, why can't you see them? Why are you bound to this one reality, unable to peer beyond the veil? And if they do exist, how do they interact with your universe, if at all? This is the multiverse paradox, a riddle that challenges the limits of understanding and questions the very nature of existence. The idea of the multiverse emerges from the fringes of science and philosophy, tantalizingly suggested by theories like quantum mechanics, string theory, and cosmic inflation. Some interpretations of quantum mechanics, for instance, propose the many worlds interpretation, where every possible outcome of every decision spawns a new universe. In one universe, you chose tea. In another, you chose coffee. In one, you turned left. In another, you turned right. Every choice, every possibility branches off into its own reality, creating an infinite web of universes. But if the multiverse is real, why can't you sense it? Why does your awareness seem locked into just this one thread? The multiverse paradox hints at a fundamental disconnect between perception and reality. It suggests that the universe you perceive is a single layer of a far more complex structure, a structure so vast and intricate that your mind can only grasp a fragment of it. You're like a fish in a pond, surrounded by water, but unable to fathom the ocean beyond. The paradox deepens when you consider the question of interaction. If parallel universes exist, are they entirely separate, like islands in an infinite sea, or do they somehow influence each other? Could the subtle forces of other universes ripple into ours, shaping events in ways you can't detect? Some physicists speculate that quantum phenomena, those strange, probabilistic events at the smallest scales of reality, might be hints of multiverse interactions. A particle taking one path instead of another could reflect a choice made in a parallel world, its counterpart taking the alternative route. But these ideas remain speculative, leaving you to wonder if the multiverse is truly beyond reach, or if its effects are hidden in plain sight. The paradox also raises profound philosophical questions. If the multiverse exists, what does it mean for your sense of identity? Are there infinite versions of you, living out every conceivable variation of your life? If so, are those versions truly you, or are they entirely separate beings with their own consciousness? The idea that every possible version of you exists somewhere can be both comforting and disorienting. It suggests a kind of cosmic redundancy where every triumph and every failure plays out infinitely, diluting the uniqueness of your choices and experiences. And yet the paradox doesn't stop there. It forces you to confront the limits of what can be known. If other universes are inaccessible to you, if they exist beyond the boundaries of your perception or your instruments of a measurement, can their existence ever truly be proven? The multiverse might be the ultimate unknowable mystery, a theory that tantalizes the imagination but defies empirical testing. If science can't confirm it and philosophy can't resolve it, does the multiverse exist at all? Or is it simply a product of your mind's need to imagine the infinite? Even if the multiverse is real, the paradox remains. Why are you here, in this universe, experiencing this version of reality? Why not one of the others? Is there something special about this universe, something that makes it uniquely suited to support life and consciousness? Or is it simply a matter of chance, a cosmic lottery in which you just happen to draw this particular ticket, the multiverse? Paradox ultimately challenges your assumptions about reality, identity, and existence. It asks you to imagine a universe, no, countless universes, far stranger and more intricate than anything you've ever known. It invites you to wonder about the unseen, the unreachable, the infinite possibilities that lie beyond your grasp. Perhaps the paradox isn't meant to be resolved. Maybe its purpose is to expand your perspective, to remind you of the vastness of the unknown and the wonder of existence. Whether the multiverse is real or imagined, whether it interacts with this universe or remains forever separate, it challenges you to think beyond the boundaries of your reality and embrace the mystery of what might be. So, as you ponder the multiverse paradox, let it awaken your sense of curiosity and awe, the idea that you might be part of something far greater, an infinite web of realities, each as rich and complex as your own, is both humbling and exhilarating. And while you may never know for sure, the act of wondering, of reaching beyond what you can see, is a journey as vast and infinite as the multiverse itself. The eternal recurrence paradox. Close your eyes and imagine this. Everything you've ever done, every thought you've had, every breath you've taken will happen again, exactly the same, over and over for eternity. The joys, the sorrows, the triumphs, and the failures, all replayed in an endless loop with no variation, no escape. This is the eternal recurrence paradox, a haunting concept that asks, if the universe is cyclical, does that mean you're destined to live this life forever, trapped in an infinite repetition of the same existence? And if so, what does that mean for freedom, choice, and the meaning of life itself? The paradox begins with the idea of a cyclical universe. In some cosmological theories, the universe isn't linear, with a beginning and an end, but cyclical, oscillating between expansion and contraction in an eternal cycle of big bangs and big crunches. Each cycle gives rise to a new universe, which evolves, ages, and eventually collapses, only to be reborn again. But if the laws of physics remain constant, if the same initial conditions always produce the same outcomes, then wouldn't each cycle of the universe be identical? Wouldn't every atom, every star, every human action repeat itself endlessly, like a cosmic rerun that never ends? The philosopher Friedrich Nietzsche famously explored this idea, not as a scientific theory, but as a thought experiment. He asked, what if you were told that your life, down to its smallest details, would recur eternally? Would this revelation fill you with despair, or would it inspire you to embrace life so fully that you could endure its infinite repetition? For Nietzsche, the eternal recurrence wasn't just a paradox, it was a challenge. If you could say yes to this endless cycle, you would transcend despair and affirm the value of existence itself. But the paradox raises unsettling questions. If everything repeats exactly as before, what happens to free will? If you're destined to make the same choices in every cycle, are those choices truly yours? The idea of recurrence seems to strip you of agency, reducing your life to a predetermined script. Yet, the paradox also suggests that each moment is eternal, replayed infinitely in the grand theater of existence. Does this diminish the significance of your actions, or does it amplify it, making every decision resonate across eternity? The paradox becomes even stranger when you consider its implications for identity. Are you the same you in every cycle, or are you merely an identical copy, indistinguishable but fundamentally separate? If the universe resets completely, can you claim continuity with the versions of yourself that came before or will come after? The eternal recurrence paradox blurs the boundaries between self and other, past and future, forcing you to question what it means to exist at all. Science adds its own layers to the paradox. While no current evidence confirms a cyclical universe, the concept isn't entirely dismissed. Some cosmological models suggest that the universe might oscillate between expansion and contraction, though whether these cycles would preserve or reset the same conditions is an open question. Even in a non-cyclical universe, the idea of infinite repetition arises in discussions of the multiverse and the vastness of infinity. If the universe, or multiverse, is infinite, then every possible configuration of particles must eventually repeat, making your exact existence inevitable somewhere, somewhen. But here's where the paradox deepens. If the universe is cyclical or infinite, and you are destined to live this life again and again, what is the role of memory? You don't remember your past cycles, or do you? Déjà vu, those fleeting moments of familiarity, might feel like echoes of lives already lived, fragments of a memory you can't quite grasp. But is that evidence of recurrence, or just the mind playing tricks on you? The absence of memory makes each recurrence feel like the first, preserving the illusion of novelty even in an infinite loop. The eternal recurrence paradox ultimately challenges your understanding of time, freedom, and meaning. If life is destined to repeat, does that render it meaningless, a futile cycle with no escape? Or does it imbue every moment with profound significance, forcing you to confront the eternal weight of your choices? The paradox is both a prison and a liberation, a reminder that the meaning of life may not lie in its uniqueness, but in the way you choose to live it, whether once or infinitely. So, as you contemplate the eternal recurrence paradox, let it provoke and inspire you. What if this moment, this fleeting now, were to replay forever? Would you resent it, or would you embrace it as a chance to live fully, knowing that every choice echoes across eternity? The paradox isn't just a question of cosmology. It's a mirror reflecting your deepest fears and hopes, challenging you to live a life you wouldn't mind living again, and again, and again. In the end, the eternal recurrence paradox isn't about the universe at all. It's about you and the way you face the mystery of existence. Whether life is a single fleeting spark or an infinite cycle, the challenge remains the same: to live with courage, purpose, and a deep appreciation for the moments that make up your story, however many times it's told. The alien paradox. Look up at the night sky, filled with countless stars. Each one is a sun, and around many of them orbit planets. Statistically speaking, some of these planets should harbor life. With trillions of galaxies in the universe, it seems inevitable that intelligent alien civilizations exist. And yet, as far as we can tell, we are alone. No signals, no visitations, no undeniable proof. But what if they're out there, watching us, deliberately keeping their distance? This is the alien paradox, a haunting question that asks, why would intelligent civilizations avoid contact with us? And what does that say about our place in the cosmos? On its surface, the paradox is simple. If life is so likely, why haven't we found it? Or why hasn't it found us? There are many potential answers, from the hopeful to the chilling. Perhaps we're truly alone, an extraordinary accident in an otherwise barren universe. Or perhaps advanced civilizations are so different from us that they're undetectable, existing in ways we can't even imagine. But then there's a more unsettling possibility. They know about us, but they've chosen not to interact. Why would they hide? One explanation is known as the zoo hypothesis. In this scenario, Earth is like a wildlife preserve, observed by advanced civilizations that avoid direct contact to allow us to develop naturally. To them, we might be fascinating but primitive, and interference could disrupt our cultural or technological evolution. Just as we observe animals in their natural habitats without interfering, they might be content to watch us from a distance, studying us as a curious experiment. Another possibility is the prime directive approach, where advanced civilizations adhere to a strict policy of non-interference. They may see contact with less advanced species as unethical, fearing it could lead to cultural collapse, exploitation, or dependency. From their perspective, humanity might need to prove itself, solve its internal problems, achieve peace, or reach a certain level of technological maturity before earning a place among the interstellar community. But the paradox darkens when you consider the possibility that they are avoiding us for less benevolent reasons. Advanced civilizations might view us as a threat, not because of our power, but because of our unpredictability. To them, humanity's history of conflict and environmental destruction could be a red flag, a warning to keep their distance. Worse, they might see us as irrelevant or unworthy, no more significant than ants on a galactic scale. Then there's the terrifying prospect that their silence is for our protection. What if the universe is a dangerous place filled with predatory civilizations that annihilate potential rivals? Advanced aliens might hide themselves and us to keep us safe from detection. In this scenario, the quiet cosmos isn't a sign of peace, but a cloak concealing unimaginable threats. The alien paradox also raises profound philosophical questions. What would it mean for humanity to be deliberately ignored? Would it humble us, forcing us to confront our insignificance in the grand scheme of things? Or would it inspire us to reach higher, to prove that we are worthy of attention? The thought that we might not be alone and yet are deliberately left out challenges your sense of importance and place in the universe. But there's another possibility to consider. Maybe we're the ones hiding. Human civilization has only recently begun searching for extraterrestrial life, and our efforts have been limited. What if other civilizations are out there waiting for a signal from us? Or worse, what if our own fear of the unknown has kept us from broadcasting boldly, fearing what we might attract? The paradox invites you to question whether the silence of the universe is truly theirs or ours. And then there's the simplest explanation of all: time. Advanced civilizations may have risen and fallen billions of years ago, their empires turning to dust before Earth was even formed. Or perhaps they exist on timescales so vast, so alien, that our fleeting lives are but a blink to them. In this view, the cosmos might not be silent at all. We're just too early, too late, or too small to notice. The alien paradox is more than a question about extraterrestrial life. It's a reflection of ourselves, our fears, our hopes, our assumptions about intelligence and morality. It forces us to confront the possibility that we are not the center of the universe, that our existence might be a mere blip in a vast and indifferent cosmos. But perhaps the paradox's greatest gift is its ability to inspire, the possibility that aliens exist, whether they are hiding or watching or simply out of reach, fuels our curiosity, our drive to explore, and our determination to understand. The silence of the universe isn't just an absence, it's a question, an invitation to seek, to wonder, and to imagine. So, as you gaze at the stars, let the alien paradox remind you of the profound mystery of existence. Whether we are alone or surrounded by civilizations that choose to remain unseen, the search for answers is a journey that unites us, and perhaps, in seeking others, we will learn more about ourselves, the one intelligent species we know for sure exists in this vast and silent cosmos. The paradox of observation. Take a moment to consider this. If you weren't observing the world around you, would it still exist as it does now? Would the chair you're sitting on, the room you're in, or the sounds you hear continue to be? Or are they only as they are, because you're perceiving them? This is the paradox of observation, a question so profound it shakes the foundations of existence itself. It asks whether reality is something that exists independently, or if the act of observing it somehow brings it into being. The paradox finds its most striking expression in quantum mechanics. In the quantum world, particles like electrons and photons exist in a state of superposition, a cloud of probabilities where they can be in multiple places or states at once. But the moment you measure or observe them, this cloud collapses into a single, definite outcome. Before the observation, the particle's state is undefined, existing only as a range of possibilities. After the observation, it's concrete and real. This phenomenon, known as the observer effect, suggests that the act of observation doesn't just reveal reality, it shapes it. But why does this happen? And what does it mean for the nature of existence? If particles don't have definite properties until they're observed, does that imply reality itself is incomplete until it's perceived? Is the universe only real when someone is looking? This idea seems to place consciousness, your awareness, at the center of existence, making the observer a co-creator of reality. It's a notion that aligns with certain philosophical traditions, but defies the scientific intuition that the universe exists independently of you. The paradox becomes even stranger when you consider the role of consciousness. Does it require a conscious observer to collapse the quantum wave function, or is any interaction enough? For example, if a particle interacts with another particle, does that count as observation, or is there something unique about human awareness, something that bridges the gap between the physical world and the realm of experience? These questions blur the lines between science, philosophy, and metaphysics, leaving you to wonder where reality truly begins. The paradox of observation also forces you to rethink the concept of existence itself. If observation creates reality, what happens to the parts of the universe you're not observing? Is the far side of the moon there when no one is looking? Is the Andromeda Galaxy just a potentiality until someone points a telescope at it? These questions challenge the deeply held belief that reality is objective and independent, suggesting instead that it's deeply tied to the act of being perceived. Philosophers have wrestled with similar ideas for centuries. George Berkeley, an 18th century idealist, argued that to exist is to be perceived. In his view, the world doesn't have an independent reality. Instead, it's sustained by the constant observation of a divine consciousness. While modern science doesn't endorse this perspective, the observer effect in quantum mechanics echoes Berkeley's ideas, hinting at a universe where perception and reality are inseparably linked. But the paradox isn't just a question of physics or philosophy. It's a mirror reflecting your own experience. Think about how much of your reality is shaped by observation. The way you see the world is influenced by your perspective, your focus, and even your expectations. What you notice becomes your reality, while what you ignore fades into the background. In this sense, the paradox of observation isn't just about particles or waves. It's about how you create meaning in a universe that's too vast to fully comprehend. And yet, the paradox remains unresolved. Does observation truly create reality, or does it simply reveal a reality that was already there? If observation is necessary for existence, what does that mean for the universe before conscious life emerged? Did reality exist in a state of potentiality, waiting for the first observer to bring it into focus? Or is observation just one part of a deeper, more complex interplay between existence and awareness? The paradox of observation ultimately invites you to embrace the mystery of existence. It challenges you to see the universe not as a static, fixed thing, but as something dynamic, interactive, and deeply connected to your own experience. Whether observation creates reality or merely unveils it, the act of observing is itself a profound and miraculous thing, a reminder that to see, to perceive, is to participate in the unfolding of the cosmos. So, as you consider the paradox of observation, let it expand your perspective. Whether you're watching the stars or examining the smallest particles, remember that your presence as an observer connects you to the vast, intricate web of existence. And while the paradox may never be fully resolved, its power lies in the questions it raises, questions that remind you of the wonder and mystery at the heart of reality itself. The paradox of randomness. Imagine rolling a die, flipping a coin, or watching a cluster of stars scattered across the night sky. These events feel random, unpredictable, governed by chance rather than order. But pause for a moment. Is anything truly random? Or does what you call randomness merely reflect a pattern too complex, too hidden, or too vast for you to perceive? This is the paradox of randomness, a question that forces you to confront the nature of chaos, order, and the limits of understanding. At first glance, randomness seems simple. It's the absence of predictability, the lack of a discernible pattern. A coin toss lands heads or tails without any apparent reason. The numbers on a lottery ticket emerge from an arbitrary draw. But dig deeper, and the idea of randomness becomes slippery. Even the simplest events are influenced by countless variables. The way a coin flips depends on the force of the toss, the angle of release, the air resistance, and the surface it lands on. Given enough information, you could, in theory, predict the outcome with precision. Is randomness, then, just a measure of your ignorance, a placeholder for things you don't yet understand? The paradox grows when you turn to nature. Consider the patterns of tree branches, the shapes of clouds, or the movements of a flock of birds. At first glance, they seem random, but closer inspection reveals underlying structures. Fractals, fluid dynamics, emergent behaviors. Randomness, it seems, is often a mask for complexity. The patterns are there, but they're buried in layers of intricacy that elude immediate perception. In the realm of mathematics and science, randomness takes on a more precise form. Random numbers, for instance, are used in cryptography, simulations, and algorithms, yet generating true randomness is surprisingly difficult. Computers, which rely on deterministic processes, can only produce pseudo-random numbers, sequences that appear random but are generated by predictable formulas, even in systems designed to embody chaos, like quantum mechanics. Randomness has rules. The behavior of particles is probabilistic, not arbitrary, governed by the precise mathematics of the wave function. Randomness, in this sense, is constrained by laws that give it structure, even if that structure is probabilistic rather than deterministic. The paradox of randomness also emerges in the human experience. Think of the events that shape your life. Chance encounters, unexpected opportunities, moments of serendipity. They feel random, yet looking back, you often weave them into a narrative, finding connections and meanings that turn chaos into a story. Are these patterns real, or are they a product of your mind's need to impose order on a chaotic world? Does randomness truly exist, or is it simply the name you give to things you don't yet understand? Philosophy adds another layer to the paradox. If the universe is deterministic, governed by unchanging laws, then nothing is truly random. Everything follows from what came before, like an intricate domino effect. But if there is randomness, where does it come from? What creates events that are uncaused, unconnected, and unpredictable? Is randomness a fundamental feature of the universe, or is it an illusion born from your limited perspective? The paradox deepens further when you consider randomness as a source of creativity. Evolution, for example, relies on random mutations to drive the diversity of life. Art and innovation often thrive on chance encounters and unexpected insights, yet these random seeds only bear fruit in the context of systems, natural selection, artistic skill, human ingenuity that shape and refine them. Randomness, in this sense, is never truly independent. It's always part of a larger framework that gives it meaning. The paradox of randomness ultimately challenges you to rethink the nature of chaos and order. It invites you to see randomness not as the opposite of structure, but as its hidden partner, a source of possibility and complexity that underlies the patterns of existence. Whether randomness is real or an illusion, it serves as a reminder of the universe's infinite depth, where even the simplest events can hold mysteries beyond your grasp. So, as you ponder the paradox of randomness, let it awaken your curiosity and humility. Embrace the beauty of the unpredictable, the moments of surprise that break the monotony of certainty. Whether randomness is fundamental or simply the edge of your understanding, it offers a window into the profound complexity of the world and your place within it. In the end, the paradox isn't just a question of what randomness is, it's an invitation to marvel at the intricate dance of chaos and order, where every coin flip and every star-filled sky becomes a doorway to wonder. The infinite regress paradox. Imagine tracing a line of dominoes, each one knocking over the next. As you follow the chain back, a question begins to form. Where did the first domino come from? Was there a starting point, or does the chain stretch infinitely into the past? This is the infinite regress paradox, a riddle that questions whether the universe has an ultimate beginning or whether every cause is just another effect in an endless loop. It's a paradox that pulls at the very threads of existence, asking whether the cosmos has a foundation or none at all. The paradox begins with a simple observation. Everything seems to have a cause. A tree grows because a seed was planted. A river flows because of gravity pulling water downhill. Your very existence depends on an unbroken chain of ancestors stretching back through the millennia. But if every effect has a cause, where does the chain of causation end? If you keep asking, what caused that, over and over, you're left with two unsettling possibilities. Either there's a first cause, something uncaused that started everything, or there is no beginning at all, just an infinite regression of causes. The idea of a first cause has deep roots in philosophy and religion. Aristotle called it the unmoved mover, something that sets the universe in motion without being moved itself. In many religious traditions, this first cause is identified as God, a transcendent being that exists outside the chain of causation. But this raises its own questions. If God created the universe, who or what created God? Claiming that the first cause is uncaused feels like a sleight of hand, a way of sidestepping the very problem it's meant to solve. On the other hand, the idea of infinite regress is equally perplexing. If there's no first cause, then the chain of causation stretches back forever, with no beginning and no ultimate explanation. This defies your intuition, which demands a starting point, a place where everything began. How can something exist without an origin? How can the dominoes fall if the line has no end or beginning? The mind struggles to grasp the concept of infinity, a vastness so incomprehensible that it feels more like an abstraction than a reality. Modern science doesn't resolve the paradox, it only deepens it. The Big Bang Theory suggests that the universe had a beginning, a moment when time, space, and matter sprang into existence. But what caused the Big Bang? Some physicists propose that our universe emerged from a quantum fluctuation, a random blip in a vacuum of nothingness. But this nothingness isn't truly nothing. It's a field brimming with potential, governed by laws of physics. And then you're back to the same question. Where did those laws come from? The chain of causation continues, slipping further into the infinite. Other theories, like the multiverse or cyclic universe models, suggest that the universe has no beginning. Perhaps it's part of an eternal cycle, a series of expansions and contractions with no first moment. Or maybe it's one of countless universes in a multiverse, each one bubbling into existence from some larger, incomprehensible framework. But even these grand theories don't escape the paradox. What created the multiverse, or the cycles? What lies beyond the edge of eternity? The infinite regress paradox also forces you to confront the limits of human understanding. Your mind is wired to seek causes, to find explanations, to look for patterns. But when you push this instinct to its limit, you arrive at a place where answers dissolve into more questions. Maybe the universe doesn't have an ultimate cause because your concept of causation doesn't apply at the cosmic scale. Or maybe the paradox reveals the edges of your intellectual horizon, a reminder that some mysteries might remain forever out of reach. And yet, the paradox is more than a problem. It's a mirror reflecting your deepest fears and hopes. The idea of an ultimate beginning offers comfort, a sense of purpose and origin. But it also raises the unsettling thought that the universe, and perhaps your life, is the product of a singular, uncaused event. Infinite regress, on the other hand, offers no origin, no foundation, no satisfying explanation. But it also suggests a universe that is endlessly rich, eternal, and filled with infinite possibilities. The infinite regress paradox ultimately invites you to embrace the mystery of existence. It challenges you to think beyond beginnings and endings, to confront the vastness of the cosmos without expecting it to conform to your understanding. Whether the universe has a first cause, an infinite loop, or something beyond comprehension, the paradox reminds you that existence itself is a profound and miraculous thing, a riddle that may never be solved, but is always worth pondering. So, as you trace the chain of causes in your mind, let the infinite regress paradox expand your perspective. It's not just a question of where the universe came from. It's an invitation to marvel at the fact that it exists at all. Whether the cosmos has a beginning or stretches infinitely, the paradox holds a quiet truth, that the search for answers is itself an act of wonder, connecting you to the boundless mystery of being. The conscious universe paradox. Close your eyes and take a deep breath. You are alive, aware, thinking, feeling. You are conscious not just of yourself, but of the universe around you, the stars, the oceans, the people. Now ask yourself, what does it mean to be conscious of the universe? Could it mean that the universe, through you, is conscious of itself? If you are part of the cosmos, woven from the same stardust that forms galaxies, does your awareness mean the universe itself has awareness? This is the conscious universe paradox, a profound question that challenges the boundaries between self and cosmos, mind, and matter. The paradox begins with an undeniable truth. You are a product of the universe. Every atom in your body was forged in the heart of a star. You are not separate from the cosmos. You are a small, intricate piece of it, and yet, here you are, capable of reflecting on its vastness, marveling at its mysteries, and pondering your place within it. Your consciousness feels personal and individual, yet it arises from the universe itself. So, is your awareness just yours, or does it belong, in some way, to the cosmos? This idea that the universe might be conscious through you blurs the line between subject and object. In one sense, You are an observer, looking out at a vast, indifferent universe. But in another sense, you are the universe, a collection of its particles organized in such a way that they can think, feel, and wonder. Does this mean that the universe, in creating you, has created a way to observe itself? Are you not just a participant in the cosmos, but a part of its self-awareness? Philosophers and scientists have grappled with this paradox for centuries. Some see it as a poetic metaphor, a way of expressing the interconnectedness of all things. Others take it more literally, suggesting that consciousness is not just a property of individual minds, but a fundamental aspect of the universe itself. This idea, known as panpsychism, proposes that consciousness is woven into the fabric of reality, present in everything from subatomic particles to galaxies, but only fully realized in complex systems like the human brain. But the paradox raises unsettling questions. If the universe is conscious through us, does that mean our awareness is cosmic in nature, or is it an illusion created by our individual brains? And if the universe is aware, what is it aware of? Does it experience joy, sorrow, or meaning? Or is its awareness as vast and indifferent as the cosmos itself, beyond anything we can comprehend? Science complicates the paradox further. Consciousness remains one of the greatest mysteries in neuroscience. We can measure brain activity, map neural pathways, and even identify areas of the brain associated with certain thoughts or emotions. But no amount of data explains why you experience these things subjectively, why there is something it feels like to be alive. If consciousness is such an enigma on the scale of an individual, how could it possibly apply to the universe as a whole? The paradox also invites you to rethink your relationship with the universe. If your consciousness is an expression of the cosmos, what does that say about your place in it? Are you a fleeting anomaly in an otherwise unconscious universe, or are you an essential part of its nature? The paradox suggests that the boundaries you perceive between self and other, mind and matter, observer and observed, may not be as solid as they seem. You are not separate from the universe. You are its expression, its voice, its witness. This idea resonates with spiritual traditions and philosophical systems that see consciousness as fundamental to existence. In Hinduism, for example, the concept of Brahman describes a universal consciousness that permeates all things, with individual minds as reflections of this greater whole. Similarly, some interpretations of quantum mechanics suggest that the act of observation plays a role in shaping reality, hinting at a profound connection between mind and cosmos. But the conscious universe paradox isn't just a question of metaphysics. It's a mirror for your own experience. Every time you gaze at the stars or marvel at the complexity of life, you're participating in the paradox. You are the universe, contemplating itself, a fragment of reality looking back at the whole. This realization can be both humbling and exhilarating, a reminder of your smallness and your significance all at once. So, as you ponder the conscious universe paradox, let it open your mind to the profound mystery of existence, whether consciousness is a property of the universe or a fleeting phenomenon of the brain. The fact that you can ask these questions is extraordinary. The universe may be vast, ancient, and impersonal, but through your awareness, it becomes something more, a self-aware cosmos, a story told through countless voices, including yours. Perhaps the paradox isn't meant to be solved. Perhaps its purpose is to remind you of the wonder of being, the miracle of awareness, and the infinite depth of the universe that created you. You are the universe's eyes, its thoughts, it's curiosity. And that, in itself, is a mystery worth celebrating.